All right, we're back. We're on page 2 of notes 26 from Calc AB, but it's about integration by parts. So whatever calculus you're taking, this might very well apply to you. So we're going to do this example. And so we remember, hopefully, that when doing integration by parts, we're going to say that the integral of u dv equals u times v minus the integral of v du. So we have to choose u and we have to choose dv. You choose u so that you can take the derivatives. Hopefully they get simpler. You choose dv, that's the key one, so you can actually integrate it. If you can't integrate it, you can't do it. So we are going to make our choices here. So from experience, I know that I'm also not going to be switching markers a ton of times here, or colors, I guess I should say. So I'm going to say that I need a u and I need a dv. All right. So if I pick u is equal to e to the x, the derivatives never change. Whereas if I make dvx dx, the integral of that actually gets more complicated every time, and it seems like things will just get worse. So I'm going to choose u is equal to x, because then du is just dx, and that's pretty nice. And then dv is e to the x and dx. Basically, dv is everything left over. But I'm always thinking, can I integrate it? If I can't integrate it, then forget it. And then so v would be e to the x. Okay, so now we're ready to do it. So it's the integral of x e to the x dx should be equal to, so I want u times v, so that's x e to the x, and then minus the integral of v du, so that's e to the x dx. So minus the integral of e to the x dx. Okay, so that's x e to the x minus the integral of e to the x, just e to the x, and then plus c. And that's it. So you make your choice. If you choose wrong, let me just demonstrate choosing wrong. So this would be wrong, right? So say you make u equal e to the x. So then dv has to be x dx. So du is going to be e to the x dx, which isn't like the end of the world. But v is now 1/2 x squared. So at this point, I have 1/2 x squared e to the x minus the integral of v du is 1/2 x squared e to the x. Doesn't this integral, so this, I mean, I'm just like blabbering on about it. That integral is harder than the original, right? So like this is clearly going the wrong way. So this is actually harder than the original. That's usually a key that you would definitely be going the wrong way. Stop what you're doing and back up. Sorry, my other computer has gone to sleep. Gotta wake it up again. Okay, so just, use common sense, right? So you pick u so that the derivatives get easier, preferably. But the real key is dv. You have to be able to do it. So let's look at this. So this is that's it. Those were our examples of the basic of integration by parts. Let's look at something a little more complicated. So here, we're just going to integrate the natural log of x dx, which doesn't seem like there's necessarily enough information there, but there is. You just have to be kind of weird about it. So we need to pick a u and we need to pick a dv. So let's say that u is the only thing we see. And then dv is everything that's left, but what's left over? It's just dx. This is kind of neat. These might be my favorites. Actually, I'm going to say that about everything. But where you just let dv equal dx, it's like very cool. It doesn't seem like it should work, but then often it does. You get 1 over x dx. Here we get x plus c, but you save all your plus c's until the very end. All right, so the integral of the natural log of x dx is, so it's uv minus the integral of v du. So u times v is x ln of x, and then minus the integral of v du. So x times 1 over x, and then dx. So I guess I could write that, but I don't really want to. Times 1 over x dx. But x times 1 over x is just 1. So this is x ln of x minus x, and then plus c. So I recommend that you memorize. So this is mostly so when you get to like Calc 3, you can just like have it available and use it. But I recommend that you memorize the integral of natural log of x. It's not that hard. X ln of x minus x plus c. But if you forget it, this is one that you can always do by doing integration by parts, but you have to make this weird choice where dv is equal to dx. And it's kind of cool that it works that way. Let's do another one that works that way. So this like, how do you know when to use this technique? I don't really know. You like look at it and you think, I don't know the antiderivative of that. So that's one way. But you also think like, I do know the derivative of some part of this. So maybe that's going to be helpful. And you just kind of go from there. So let's make our choices here, by which we don't really have a choice at all. So we're going to say u is sine inverse. And then hopefully we memorize the derivative of sine inverse. dv is dx. It's really important that I put a tail on u because my u's and v's are like almost totally indistinguishable. All right, du, derivative of sine inverse, 1 over square root of 1 minus x squared, and then a dx. That's in the numerator. It doesn't really look like it, but it is. And then v is x. Okay. So the integral of sine inverse, or arcsine, depending on how you want to say it, is going to be u times v, so x sine inverse, and then minus the integral of v du, which is x times 1 over root 1 minus x squared dx. So let's write that as x over radical 1 minus x squared dx. Okay, so far so good. Now we just have to integrate this. So there's a lot of choices you can make. You can do like a u substitution on this if you want. You could say, for example, u is 1 minus x squared. So then negative 1/2 du is going to be x dx. And then you can do your substitutions. So should I do that? I don't know. I'm just going to integrate it. So x sine inverse of x. But what I'm going to do is like a little dangerous, right? So there should have been a negative 2 on the top. So I'm going to put a negative 1/2, which gives me a plus 1/2 because minus negative 1/2. And then it's like u to the negative 1/2. So plus 1 times the reciprocal is 2 square root of 1 minus x squared, then plus c. So let's write our final answers. X sine inverse of x plus square root of 1 minus x squared plus c. So this is the antiderivative of arcsine. So can we check it? We could check it by taking the derivative. I'm going to check it by using the calculator to integrate it. Let's see what the calculator says. So integral of arcsine of x with respect to x. So we get x arcsine of x plus radical 1 minus x squared, which is exactly what we got. Calculator never puts plus c. Minus infinity points to the calculator. So let's see. I don't think there's any reason to memorize this. You're welcome to it if you want. We're done with another page, and I feel like doing more than one page in a video is kind of like a bit much, so I'm going to cut this here, come back in the next video, and keep going. Hope you're finding these helpful, and I will see you then.